choice education living on.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So previously we talked about how looking at the equilibrium constant K, we can tell which way the reaction is going to be favored, whether it's going to favor the reactants or whether it's going to favor the products. But how will we determine which direction the reaction will proceed if the system hasn't reached equilibrium yet? So in that case, we have to use the reaction quotient, which is denoted as Q. And this can be used at any time during the reaction, and then we can compare it to the equilibrium constant, where this denotes a point in time where a system has already reached equilibrium. So Q or QC or QP, just like when we talked about K, KC, and KP, can be calculated in the exact same way as the equilibrium constant K. So basically Q is always going to be the concentration of the products over the reactants. But now by comparing Q to K, we can figure out which direction a reaction would proceed. So if Q is less than K at some time during the reaction, then that means that the concentration of the reactants are greater than the concentration of the products. What does that mean? The forward reaction is favored, meaning that more products would be made. So let me draw out the reactant to product like so. So basically, if the concentration of the reactant is greater, equilibrium is going to shift to the right and it's going to be forward. On the other hand, if Q is greater than K, you guessed it, it's going to be the exact opposite. Products are going to be greater than reactants, meaning that you have more product, it's going to shift to the left, and it's going to favor the reverse reaction. Okay, so now let's do an example of this. Alright, so in this example, we're going to use N2O4, which is a gas, going to 2NO2. The equilibrium constant for this equation is 1.7 times 10 to the power of 3. This is given to us. But then they ask you when the partial pressure of NO2 is 0.5 atmospheres and the partial pressure of N2O4 is 0.5 atmospheres, is this system at equilibrium? Is it at equilibrium? So that's the question, and we have to figure it out by using the reaction quotient. So let's do that. So QP, since we're talking about gases, let's do the partial pressures. It's going to be the partial pressure of the product, NO2. Remember, there's a coefficient right here of 2, so we're going to square it, over the partial pressure of N2O4. So we have 0.5 atmospheres squared over 0.5 atmospheres. And what do we end up with? A value of 0.5. Now if Q equals 0.5 compared to K, we see that the partial reaction quotient is less than Kp. So this means the system is not at an equilibrium. And by looking at what we showed you before here, when Q is less than K, it means that the reactants are more than the products, and so the reaction is going to proceed towards the products and it's going to favor the forward reaction.
24 hot flush, brown-eyed girl making no